In today's video, I'm going to outline the fundamental trig identities and how they are used to simplify trig expressions. First, let's do a quick recap on the identities we know so far. Earlier in the year, we learned our reciprocal identities for each of the three functions and the quotient identities. Now, when you're trying to remember which one is which, remember that the quotient identities actually divide two functions, which is why they're called a quotient. The reciprocal identities simply tell us which two functions are reciprocals of one another. An important thing we need to remember is that we have to always use the theta when we are writing our functions. For example, it is wrong if you were to say something like tangent equals sine divided by cosine without the theta. We need to say tangent theta equals sine theta over cosine theta. This is a common mistake that students make, so try not to get into bad habits while you're doing your homework. Recall the Pythagorean identities that we learned earlier in the year. When we use the Pythagorean identities, we'll be using them for substitutions. So we want to remember that wherever we see the sine squared plus cosine squared theta, that we can replace that with 1. We also want to be familiar with thinking about these identities rearranged in another way. For example, I could take this bottom identity and I could write this as cotangent squared theta minus cosecant squared theta is equal to -1. All that I did was move the two terms from one side to the other, and I have an equivalent expression. Alright, now let's talk about our negative angle identities. These are new. We have not talked about these before. Basically, the whole idea of theta versus negative theta is what would this angle look like on a graph. So if I were to draw my regular chart and I were to represent an angle, let's say for example 30 degrees, sine of 30 degrees would equal 1/2. Now, if I wanted to find sine of negative 30 degrees, sine of negative 30 degrees would be a mirror image of sine of positive 30. And the only difference is that now I am down in quadrant 4. And in quadrant 4, sine is equal to negative ratio, so this answer would be equal to negative 1/2. Now, what we want you to notice here is that for sine, no matter which angle I were to pick, anything in the top side of the circle from 0 to 180 would be a positive sign, and if I were to pick anything on the bottom end of the circle, -0 to -180 would be a negative angle. So for that reason, I can say that no matter what angle I have, if I take the negative of that angle, it's the same as negative of the positive. Alright, let me rephrase that. So when I look at this sine of negative 30 degrees, basically I'm just thinking that I'm going backwards, and sine of positive 30 is equal to 1/2, but when I go backwards, I now get it equal to -1/2. And that's going to be true for sine and its reciprocal cosecant, and also tangent and its reciprocal cotangent. Now, cosine, on the other hand, is different. If we were to look at our same problem and do cosine of 30 degrees, we know that cosine of 30 is equal to √3/2. Now, if I looked at cosine of negative 30 degrees, this is also equal to √3/2. And the reason why for cosine that the sign of the ratio doesn't change is because for cosine, the two quadrants that are top and bottom of each other, quadrants 1 and 4 and quadrants 2 and 3, have the same positive or negative sign. So cosine and its reciprocal secant are unique in that a negative angle does not change the ratio. For all the other four functions, sine, cosecant, tangent, and cotangent, a negative angle gives us the negative of the ratio. Okay, for this next problem set, you probably recall doing problems similar to this back in chapter 2 and 3. And when we did these problems back in chapter 2 and 3, we solved for x, y, and r, and we went ahead and found the appropriate values we needed, and then we wrote the ratio answer as needed. For this area of the notes, I'm going to work through these same problems using our identities. You can still solve them using the XYR method learned earlier in the year, but I want to demonstrate how our identities can be useful here. For the first problem, we are given tangent and we are trying to find secant. So things that we want to recall are different identities that we know. And it's a good idea to write these off on the side or have them on a post-it note or a note card to refer to. The identity that we're going to want to use here is that tangent squared theta plus 1 is equal to secant squared theta. I can now plug in my tangent theta ratio, and when I square negative 7/2, I get 49/4 plus 1 is equal to secant squared theta. After adding the fractions, I get 53/4 is equal to secant squared theta, and I can now square root both sides to find my secant ratio. Now, I am told in the given that theta is in quadrant 2. Therefore, after taking my square root, I know that secant is negative, and I will have negative square root 53/2. For this middle problem, I want to find sine of theta. As I stated a minute ago, you can solve these problems with the XYR, but we want to show you some additional techniques. So for this problem, if we start with our identity, our quotient identity, that tan theta is equal to sine theta over cosine theta, we can then say that we know whenever I have a 1 over cosine theta, that is the same as having a secant theta. So I can say that tan theta equals sine theta times secant theta, and then I can divide this secant theta over to the other side. So I know that sine theta is equal to tan theta divided by secant theta. And at this point, I was given tangent, I found secant, I can therefore plug those values in to solve for my sine ratio. I can say that sine of theta is equal to negative 7/2, and then when I'm dividing by secant, that is the same as multiplying by its reciprocal, so I can say times negative 2 over root 53, giving me positive 7 over root 53, and after rationalizing, I get positive 7 root 53 over 53 for my sine ratio. On part C, we are asked to find cotangent of theta. Using our reciprocal identities, we know that cotangent of theta is equal to 1 over tangent of theta. We also know, because of our negative angle identities, that that negative sign can come out front, and cotangent of negative theta is equal to negative cotangent of theta. Alright, so if I know that my tangent is equal to negative 7/2, then I know that my cotangent is going to be equal to negative 2/7. And when I take the negative of negative 2/7, I can get positive 2/7 to be my answer for part C. Okay, for example 2, we're going to also follow along and use our identities to solve these problems. So for part A, we are given cosecant and we want to find cotangent. We're going to use our Pythagorean identity. We'll say that 1 plus cotangent squared theta equals cosecant squared theta. And plugging in what we know, we get 1 plus cotangent squared theta equals positive 9/4. Subtracting 1 gives us that cotangent squared theta equals 5/4. And after square rooting both sides, we get square root of 5/2. Now to figure out the sign of our problem, we know that cosecant is negative, which would occur in quadrants 3 and 4, and we know that cosine is positive, which happens in quadrants 1 and 4. Therefore, angle theta is located in quadrant 4. And so that being said, cotangent of theta is equal to negative root 5/2. Alright, in order to find our tangent, we can simply reciprocal the cotangent, which gives me negative 2 over root 5, and after rationalizing, negative 2 root 5/5 for my tangent ratio. And then lastly, I want to find sine, and I know that sine of theta is equal to 1 over cosecant of theta, and using my reciprocal identities, I can get that this is equal to negative 2/3. The last two examples that we are going to see are involving simplifying. Now, one of the things we're going to focus on this chapter is how we can rewrite and simplify expressions using these identities. In this problem here, I'm asking you to rewrite in terms of sine and cosine and simplify our answer to one term. One term means that there are no plus or minuses separating individual trig functions. It is okay if the values are multiplied together. Alright, so first let's start by rewriting with our quotient identities. I can say that tan theta is equal to sine theta over cosine theta, and that cotangent theta is equal to cosine theta over sine theta. Now from here, in order to add fractions, we need to have like denominators. So to get like denominators, I'm going to multiply my left fraction by sine theta over sine theta, and my right fraction by cosine theta over cosine theta. Now what I end up getting is sine squared theta plus cosine squared theta, and both of these are over the common denominator of sine theta cosine theta. Alright, now that we have like denominators, we can go ahead and add across our numerator, giving me sine squared theta plus cosine squared theta over sine theta cosine theta. And you might be looking at this thinking that this looks a heck of a lot more complicated than what we started with, but we're getting there. Notice that this entire numerator is equal to our Pythagorean identity. So we can now do a substitution and replace all of that with a 1, giving us 1 over sine theta cosine theta. And we're almost there. The last thing that we want to do to finish the problem is recognizing it's always simpler if we can write it without being a fraction. And since a 1 over sine is equal to cosecant of theta, and a 1 over cosine is equal to secant of theta, this is our preferred answer here. If we ask you to stop in terms of sine and cosine, then this would be your answer. But if we ask you to simplify as much as possible, then the answer in red would be where we would stop. Alright, last but not least, these problems are just applying the different identities. So in part A, we have sine of x equals 0.4, then sine of negative x equals what? Here we want you to use our negative angle identities, recognizing that if the sine of the angle is changed, then the sign of the ratio is changed for my sine function. Therefore, the answer is negative 0.4. Looking at part B, we want you to expand cotangent with our quotient identity. So I would say negative cosine x over sine x times the rest of the problem, sine of x, and then from here, those sine x can cancel, leaving me with negative cosine of x. And then last but not least, in this problem here, we're going to rewrite with our reciprocal identities. So I can rewrite my cosecant x as 1 over sine x. I can rewrite my secant x as, or my 1 over secant x as cosine of x. And I can then multiply these together to give me cosine of x over sine of x. Now using my quotient identities, I know that this is equal to cotangent of x. Alright, now typically at this part of the game, students get really frustrated. They wonder how they're supposed to remember all of these, how are they supposed to know what to do in each time. This chapter is crucial that you are doing your homework and practicing. This is a long chapter, and in order to be successful, there are a couple things that we need. Number one, we need to know these identities. Alright, if we don't know our identities, then we can't use them for substitutions and simplification. Number two, we need to practice. Each of these problems is like solving a puzzle. And the only way we're going to get good at it and be quick at it is if we practice solving those puzzles on a daily basis. Alright, homework, Math Excel.